Hello, everybody, and welcome to a new episode of the Ampere Developer Impact. My name is Dave Neary, and today I have the great pleasure of being joined by Phil Estes of the Containerd project. Thank you for joining me, Phil.
Great to be here, Dave. Thanks for having me on.
So, Phil, we're going to talk today about a lot of things, but let me get started by asking you, tell me a little bit about Containerd. What's its role in the container ecosystem? Because I know that, that I myself get confused between container runtimes, container management, container formats, container orchestration. Can you give me an idea of how Containerd fits into the container ecosystem overall?
Sure, absolutely. So yeah, it's an interesting topic because I got involved in the Docker, runtime Docker engine project way back in 2014, and at that point, there were some other options in the industry around container runtimes, but essentially Docker is the thing that brought a lot of interest and excitement around packaging and delivering container workloads and running them. So skipping a bunch of early history and some exciting history around contentions in the industry, a consortium was formed of companies who wanted to consolidate on the format. So if you think about the OCI runtime spec and the OCI image spec, those were the definitions of what is a container, what's a container image. And Containerd came to life in that era because that was kind of the first time Docker was split into multiple projects. There was the Docker engine still, but Containerd became this intermediate piece that actually drove runc, which was the default implementation of how to run an OCI container on a Linux host.
Okay.
So it was at that point that Containerd came to life, but it wasn't really till late 2016, and then in 2017 it was donated to the CNCF. Containerd became a full-fledged container runtime, an overloaded term maybe, but similar to Creo in that it could drive runc and then crun. It could be used by Kubernetes to orchestrate containers on a host. And Docker could continue to use Containerd as kind of this lifecycle manager of its processes. And so Containerd essentially became, at least in the Docker world, the Switzerland of a neutral runtime that could be used by Kubernetes, it could be used by Docker, could be used by any sort of higher layer that wanted to orchestrate or manage the lifecycle of runtime processes. And one additional thing we did, and I think maybe we're going to talk about that later, is we made an early architectural decision to not directly connect Containerd to runc.
Right.
Essentially, we made it pluggable so that there was a shim layer that anyone could implement the shim API and drive their own kind of isolation, whether it was runc or crun or lightweight hypervisors. Intel Clear Containers was an early player there, Firecracker from AWS, and then newer things like Wasm today. So that's sort of in a nutshell, where Containerd fits in the ecosystem.
Okay. Got it. Well, so given that role that Containerd has, which is pretty central in the container ecosystem, one of the things that you've shared with me as we've talked in the past is that platform agnosticism, like platform independence, portability, is something that's a very key value for you of Containerd. Has that always been a value of Containerd, or is that something that you brought to the project when you joined?
No, I mean, I brought it initially to the Docker project along with Microsoft, who joined the project at a similar time frame as myself. I was obviously at IBM at the time, and we were thinking more along the lines of our PowerPC line or our Z systems. Microsoft was there thinking about Windows as a platform, still
Right.
on x86-64, although now there's also Windows ARM as well. So the Docker project, with our involvement and others coming along, started to think about multi-platform images. That was work we did way back in the day. But as Containerd started, it was very clear that, we had brought those capabilities to Docker, and therefore they had to exist in Containerd for parity, and support of, Microsoft's continuing interest in Windows containers and bringing that to Kubernetes. So yeah, it's been a long time kind of vision is to make sure that these projects are cross-platform.
So when did Containerd start to support ARM64 as an architecture?
Yeah, good question. So, we had interest from the beginning, and we had people kind of doing one-offs. We had everybody from Raspberry Pi enthusiasts to, AWS had Graviton early on. And so as a project, we were a little sort of hesitant to make it an official architecture until we had a way to test it properly. So our initial thing was just have nightly untested builds of several cross architectures. ARM64 was one of those. We enabled it early in 2019. It wasn't connected to CI. All it did was check out the project at in the middle of the night, build it for ARM, build it for PowerPC, build it for a couple other Windows, I believe. And so this was around the time of our 1.4 release. So, we were already a fairly stable project, lots of interest. We had multiple issues open asking us for ARM support. But it was also in 2019 that a team running a site called OpenLab, which was OpenStack based, said, "Hey, we've already enabled Containerd, and we even trigger on your pull request. We clone the project, and we're doing unit testing and building ARM64. Would you like us to integrate that?" So I think it was spring or maybe May of 2019 that OpenLab actually was triggered with every pull request and would at least build and run the unit test, but we weren't doing integration testing. We weren't testing Kubernetes integrated with Containerd. And so we didn't add it as an official build architecture at that time, again, around May.
Right.
But it actually took, I think in 2021, there was more interest from the Kubernetes community, more interest from AWS and Graviton to actually add integration testing and CRI testing. So we were still on OpenLab, but with these contributions to add, running the full integration suite and fixing tests that broke and running the Kubernetes CRI gave us enough confidence that we actually added release tarballs for ARM64 in our next major release, which was 1.5.0 in spring 2021. So, yeah.
So that's 2021. So one of the things, obviously, that we've been talking about a lot is Containerd was one of the early adopters of the Actuated pilot that was launched by CNCF, Ampere Computing, and Equinix last fall. Can you describe what was your CI infrastructure at that point, coming into summer 2023, and how did it change once you moved on to the Actuated pilot?
Yeah. So one of the things that was difficult, and this wasn't only true with the OpenLab setup, we had some tests that were running on other Linux OS variants. And so I think at one point we were triggering Cirrus CI because GitHub Actions didn't fully support what we wanted to do with virtualization inside, another virtual VM. So, that was one of the downsides, is that if you made a change to like the integration suite and change like the GitHub Action scripts, that wouldn't apply to the OpenLab CI for ARM64. And so, there was a lack of parity many times because we were improving the GitHub Actions-based CI, but not bringing that change over to the OpenLab Zool scripts that were running on OpenStack. So bringing in Actuated was awesome because now our actual matrix in GitHub Actions just had an Actuated runner and was running the exact same script. So any changes you made to CI were immediately matched in our running of the Arm64 test suite and builds on actuated runners. So, one of the obvious, initial benefits of that is that we instantly had parity between all our, common architectures, all running in GitHub Actions.
I actually have the pull request that added the ARM64 runners on Actuated here. So this is basically how simple this is. It's adding a new target to your OS matrix.
Yeah, I mean, it's beautifully easy in the sense that we already had a matrix of runners. Actuated, was enabled as a runner within our GitHub organization.
Okay.
And then just adding this, there are a few extra, packages to install because of slightly different setup in the guest.
The thing that strikes me here is how little there is that changed, right? It's very much just add a new target and you're done, pretty much.
Yeah.
And may I ask, what was the impact?
So yeah, it gave us, first of all, great confidence. And, this is no knock on the Open Lab folks. They were offering us a free service with, I think, sort of on their own time, trying to help us out. But we had some stretches of time where, we didn't actually make those triggers voting. If you know of the, GitHub pull request status, if they broke, we didn't break the entire PR because we had some stability issues, which, as you can see from that PR, we didn't do that with Actuated. Like if the Arm CI broke, then there's no way we're going to merge that PR until we figure out why. So those were two major improvements, is that we had, full confidence that it's not a flaky issue with the hardware, or maybe their OpenStack cluster is down today. We didn't have that kind of confidence. And then, the fact that Actuated had, if we did have issues, there's a dashboard, shows us our build minutes, our status. Yeah. So, this is the exact dashboard showing, from June through now, all our builds and build minutes. You can actually see, who's been submitting builds, which ones are successful and failed. I was impressed with this. I haven't had a failed or canceled build, so I guess I'm a perfect coder. No.
Or a perfect code reviewer.
Yes. Yeah, I think it's more code review than coding these days for me. So, yeah, we, you can see the runners we have. There's one assigned to us that, has 6 out of 20 VMs currently running. So yeah, this service has been, amazing for us, for visibility into what's happening. As I said, the stability of the system, and giving us that kind of clear parity. I didn't get a chance to dive into performance because our Open Lab data is old enough that there's no access to it. But I'm sure I can say that the the Ampere servers and the Arm capabilities in these systems have made it a zero impact to our overall CI time per PR, which was sometimes an issue with Open Lab, a job kind of dragging on because of performance.
So it's basically allowed building for ARM64 to become a seamless part of your CI.
Yeah, definitely.
Okay. And roughly how many minutes is this for since the start of the pilot, or is this
no, this is
only for a month?
Yeah, this is just the last 28 days. So, so yeah, we heavily use. I mean, we have a fairly active community. We're about to do our 2.0 release. There's a lot of PR activity, and these systems have kept up with the load, and we have no issues with any of it slowing us down or keeping us from making progress toward our release.
Let me ask about, in general, your predictions about the Kubernetes world in a post-container world. Like, obviously, you've worked with the folks in Fermyon and Microsoft to support WASM bundles running in in containers, well, running in Kubernetes pods with SpinCube. Where do you see that going? Do you see that becoming a kind of a norm, that Kubernetes will be managing things other than containers very soon? Obviously, with KubeVirt, we already have Kubernetes managing VMs. Is that going to become kind of the standard, where Kubernetes is just your compute infrastructure management, regardless of what it looks like?
Yeah, definitely with KubeVirt, with some of the work around Firecracker, and I always forget the name of the. There's another project out of the Chinese cloud consortium called Quasar that also is. I think they can plug into Containerd to run VMs, WASM, and containers all within the same cluster. So there's been a lot of interest in this space for a little while.
Mm-hmm.
And I think what I expect to see is that, because we've kind of abstracted the idea of OCI being not just about containers, but in our latest OCI image spec and distribution spec, this notion of artifacts. There's other things I can package as an OCI image, whether that's a VM tarball or a WASM runtime, workload packaged as such. That gives some freedom, along with our sort of shim layer, to anything that you want the same set of characteristics. I want to start it, I want to stop it, I want to get its logs, I want to pause it. That if those same semantics can apply to a workload type, then obviously it's simplest if we don't have to have, that's not Kubernetes, that's this other platform we have to use when we run that workload.
Right.
There's some simplicity to having, the holy grail has always been the single pane of glass. I'm managing everything, from this one, one API or one dashboard. I see that continuing. I think it seems like with each evolution, there's this big sort of hype and fear at the very beginning. This is the end of containers because now it's WASM. And I think what we've seen is that people are, just like with the major cloud providers, there's people that want to do some functions and some containers and Kubernetes as part of their entire suite of like workload operations on various compute platforms.
Right.
And I think we'll continue to see that. There was an interesting keynote from the SpinCube and Microsoft folks at KubeCon with Zeiss Optical, I think it was.
Yep.
And they were saying, like, we like this because not all of our workloads are going to be WASM, but this one very intensive sort of latency sensitive workload we really want, to run as WASM workloads. But hey, we also have containers running in traditional pods. I think we're going to see that continue as people explore and figure out how to manage that that kind of mix of workload types.
Yeah, we actually had Michelle, Ralph, and Kai from Fermion, Microsoft, and Zeiss on the guest recently. Yeah. So I'll point to in the show notes. I'll point to that video as well, and you can learn a lot more about WASM and how they've been using WASM to abstract away essentially the hardware platform. That allows you to choose the cheapest compute that fits for that use case. And right. in that case, it was Ampere VMs running on Arm64.
Yeah.
It's exciting times, and I'm actually really excited to see the way that Containerd has avoided falling into the trap of being tied to a specific technology to enable you to run that as workloads evolve, that you can run functions or VMs or containers.
Yeah, exactly. Yeah.
Phil, thank you again for joining me today. I look forward to seeing everyone on a future edition of the Ampere Developer Impact.
All right. Thanks for having me.